Hey there, math fans. When you do the cross product, the order actually does matter. There's this so-called right-hand rule to help us visualize it. I'm going to talk about that here, do sort of the technical piece, and then I'm going to follow it up with some visuals of how many places in your life you see this. I've taken videos of 3 sort of everyday examples. So I'll follow up with a separate video on that. That'll be more interesting. But briefly, let's go through this. So if you do the cross product of these two vectors, I've shown it to the right, and I'm going to give you some visuals and explain, this is what you get. So I'm going to lay out my template, watch my previous video for how I suggest you do cross products, how to build your routine so that you never make an error, and also so that you can hold the fewest amount of things in your head. I'm going to do this in both orders. I would encourage you to try to compute it yourself. With practice, not only can you do this, but you can also check your work, as I talked about in the previous video. So there's no reason to get this wrong. So we cover up the first column, main diagonal, 0 times 0, off diagonal, 3 times 0. So this is 0, 0. It's that nice. Cover up the second column, main diagonal is 0, off diagonal is 0. Cover up the third column, main diagonal is 6, off diagonal is 0, and then I summarize 0, 0, 6. I check that that's perpendicular to the previous two vectors. Check, check. That's so quick. 0 plus 0 plus 0. Done. We would say that that vector points upward. And so what I've done here is, so we have this is U, this is V. Oops, I did the wrong colors. I meant to do this in blue to match up my picture, and this in red. That's V. And we did it in the following order. We did this first, and we did this second. Now, the way I think about it is a little different than what I saw in the textbook, but anyways, I think about it as we went from there to there. We went counterclockwise. Whenever it's counterclockwise, the vector comes toward you. This is toward us. So from our perspective, this looks like it's counterclockwise. It's going to come towards us. And here's the visual. I'm going to move a couple things around so you can see it. That's that green vector that points up. But I'm going to continue to put it in our perspective as if we're looking down on the thing. So we're looking at it, it's coming towards us. Okay, now let's do the other. So we'll put a little line here separating these two. We'll do the cross product yet again. Main diagonal is 3 times 0. You'll notice it's the same numbers, but in flipped order across this. So it's cover up the second column. Main diagonal is 0. Off diagonal is 0. Cover up the third column. You get 0, and then you get 6. You get 0, 0, negative 6. So this one's away from us. In this course, all that really matters is that you recognize those are not the same. That if you do U cross V and V cross U, they point opposite ways. It means it's not a commutative operation. You know, in 2D, we can sort of state the same observation. So in this case, this is what we were doing. And I'm just trying to say this in as many different ways as I can. Students are always confused by this. It's not really that important of a rule in this course, but it is an important rule in like a physics engineering course. This time we were going this first and this second. So in my mind, I think of it as going this way, which is clockwise. So if it's clockwise from our perspective, then it's away from us. If it's counterclockwise, it's towards us. And those are those two vectors that you see here. So the yellow vector was away from us, and the green vector was towards us. Now that begs the question, what if I was standing on the other side? Then the second one's towards us. Somebody realized that this is kind of a problem. So they say, well, what? It's true no matter what. And it's the so-called right-hand rule. So when I was taught this, I'll show you, it will impose, I'm going to show you something here. Here's my right hand. So what most people are taught is to think of the first vector, or in some cases the x-axis, as being their pointer finger, their first finger, first vector, first finger. Think of the second vector as their second finger. And if you point those in the direction of whatever two axes you're talking about, your thumb will point in the direction of the cross product. I was never taught that way, so it's harder for me. I'm going to show you how I think about it. Let me use my thumb for a second. Okay, so if I'm going from U to V, I think of putting my hand on U so that my wrist is where the vectors meet, and then I curl my fingers towards the second vector. That's how I think of it. You might say, well, why don't you put your hand? If you try to flip your hand over, I am unable to curl my fingers without breaking them. They do not curl that way. So you put your hand with your wrist at the tail of the vector and your fingers pointing the direction of the first vector, and you orient your hand so that your fingers can curl towards the other vector. So it's got to be like this, which means it's towards us. You can also use the method of first finger points towards the first one, second finger points towards the second one, towards us. Cool? That works if you're looking at it from either side and you go from the first vector to the second vector. Okay, now if we say that the red vector is the first vector, then we have to put our fingers pointing up. Now the moment we do that, we can't curl our fingers the correct way, right? We need them to curl towards the other one. And in the moment I do that, my thumb points down. No matter how I explain that, students tell me it's confusing. So it's probably me. I'm not a good explainer of things. This is a visual of the first one. So the first one, what we're doing, sorry, I went to move this one, is we're going from here to here. And if your fingers curl like that, take your right hand, curl your fingers, and you should see that your thumb comes towards you. Now, when you're doing the right hand roll and you're doing it in the other order, you're starting here. If your fingers of your right hand curl that way, think about how it forces your hand to be. And it forces your hand to point away from you. Okay, so I don't know if any of that's helpful. If another way to say it, if from our perspective it's counterclockwise, it's towards us. From our perspective, if it's clockwise, it's away from us. That's the idea. The main thing to recognize is it does point in different directions, but I'm going to follow this up with several examples that I find interesting on this concept. All right.